let's really get into complex number. So what exactly is a complex number? Now, a complex number is slightly different. Okay, so this is what you need to write down to your note for here. A complex number is any number. Of two components. Now, so we're talking about number these days now have two components. The A component and the BI component. That is a complex number. So it's any number of two components, A plus BI. Okay? So a complex number is any number of two components, A plus BI. So the first component right here, you can see the two components here. There's one component goes without the I, by itself, alone. And we call that the real component. Okay? We call that the real component. And there is another component here that goes together with the I's, always, right? We call that the imaginary component. So you have just learned about the component, the imaginary number just earlier. So now the imaginary component here coming together with the real component makes up a fine-looking complex number. All right. So now let's start looking at a couple examples of complex numbers. So the first complex number I can give you here. So example. Okay. So for complex number. Now, we try to find out if the numbers I give you here are complex numbers. So how about we have the first part here is 2 plus 3i. Is this number here the whole thing? The dual nature number, the number with two components like this, right? Is that a complex number? And the answer here is yes. Okay, why is that? Because that's the real part, right? The real part is 2, and this is the imaginary part, right? The imaginary part. So we got it looks just like the number 2 plus 3i right here. It looks just like A plus BI as we want. So yes, this number here is a complex number. Okay. So now let's look at another example. Now, so how about we got 5 minus I. Okay. So is this a complex number? Yes, it is a complex number again. So where's the real part? The real part is A is a 5 in here. And I don't see it looks like I don't see an imaginary component here, but yes, it is there. The imaginary component B here is a minus 1, because you can think of the minus I right here is the same as minus 1i. Okay, so the imaginary component for this complex number here is the minus 1. So yes, this number here is as well a complex number. Okay, so now what else can we think of? Now let's say, how about just simply 3i? This number right here, 3i. Is that a complex number? Now, all of a sudden, you just don't see the real components any longer, right? You only see the I parts, the 3i part. You don't see, what about the A plus with the 3i here? There's the point is you don't see that real component, right? So the truth here is revealed that 3i is the same as a 0 plus 3i. Now I am seeing my real component. So my real component is still that's my real component, which is a 0. And my imaginary component is the 3 plus 3. So the bottom line here, even though you don't see the real component, 3i is still also a complex number. Alright? And even further, how about we have just simply, let's look at some of the usual numbers we've been working with. Let's say 10. Okay, is this a complex number? You might think it's not, and indeed I have received a lot of ideas from my students in the other class saying that this number 10 is not a complex number. However, the way I see it is 10. You can rewrite it as 10 plus a 0i. Now 0 right here is my imaginary component, and of course 10 here is the real component. So yes, 10 here, even though it doesn't look like a doesn't look like a complex number, but yes, you can always regard to it as a complex number. So 10 is also a complex number. So it's pretty much any number now these days is a complex number, right? So some of my students can already quickly recognize that the rule here to remember now is that the rule to remember is all numbers now. All numbers, right? All numbers are complex numbers. All numbers now are complex numbers. Right? Alright, so now in another example to get acquainted, to get more familiar with complex numbers. So let's say this time we're asking the question which of the following, right, is a complex number. Okay? So the first one right here, if it's a yes, put a check mark next to it. If it's a no, put a cross. Okay? So how about 1/2 plus 2i? Is this a complex number? I can see 1/2 here is actually in the role of my real component, right? And the imaginary component is a 2. So I have enough. I see the 2 parts here with me. So yes, that is a complex number. Okay? So how about in another example right here? How about we have to simply 1/5 I. So what I'm seeing here is a number 1/5 times I, right? I do not see the real components anywhere. However, remember in the previous example we had, even though it's appearing here as a imaginary component only. However, we can always regard to that as 0 plus 1/5 I. So yes, this is also complex number. So how about the next one here? We have to simply 3/2 here. You don't see the complex, you don't see the imaginary components anywhere. But however, once again, the trick here is you can write that number 3/2 as 3/2 plus 0i. And so now at this point, at this time here, at this point, you're seeing that it is also a complex number. Okay? And so another example you can see. So this one, we can have like 0.25 here, and minus 3.14i. Okay? Now the numbers, the number part looks kind of weird. I mean, it looks kind of not whole number. However, is this whole thing right here a complex number? And the answer is yes, once again, because we're just simply having 2 components. There's a real component and there's the imaginary component just right there, minus 3.14. So one last one, easy one for a day. 1 plus I, is that a complex number? Yes. Okay? The real component is 1. The imaginary component is I. It's 1i. Alright, so that is the basic idea of complex numbers and imaginary numbers.